Alright, here we go. Lesson 1.2, Forms of Rational Numbers. We have 4 total learning objectives for this lesson. Go ahead and get these written down before moving on to the next slide. Here's our introductory problem for this lesson. Go ahead and pause the video and read it before moving on to the next slide. The first thing we're going to be talking about in this lesson is identifying a rational number as a ratio of 2 integers. Okay, so we've got some numbers are considered rational numbers. A rational number is a number that can be written as a ratio. So what is a ratio? A ratio is a comparison of 2 numbers. So for example, you might discover that the ratio of boys to girls in your class is 12 to 13. Now what that means is you've got 12 boys and 13 girls. That same ratio could also be expressed using a colon, so this is 12 to 13 as well, or we could represent it as a fraction, 12 over 13. Okay, so basically, any number that can be written as a ratio of 2 integers is classified as a rational number. Okay, so let's take a little closer look at how we're going to identify these rational numbers. Okay, so how can we determine if an integer is a rational number? Well, let's take a look at an example and see if we can write it as a ratio. 10 is a number that can be written as a ratio. Every whole number can be written over 1. So you could have 10 over 1, 6 over 1, negative 3 over 1. Hey, any integer that you could think of, we can write it as a fraction or a ratio by putting it over 1. So now notice that the fraction bar is a way to tell if the integer can be written as a ratio. In other words, if it can be written as a fraction, it's a rational number. So 10 is a rational number. And also these other 2 examples. So 6 would be rational and negative 3 would be rational. Because again, I can write it as a fraction. So what happens if we're given a fraction to begin with? Well, let's talk about 2/3. Okay, so 2/3 is a fraction that is a rational number and is written as a ratio already. We are comparing the numerator to the denominator. Okay, so in this case, yeah, it's negative 2/3, and that's okay. We can have negative fractions and they are still considered rational numbers. So when we have whole numbers, we put them over 1, and we have a ratio. If we are given a fraction, it doesn't matter what's on the top and what's on the bottom, like 4/7 or 10/7 or 2/11. Okay, these are all ratios. We're comparing the tops to the bottoms. Now what happens if we're given a decimal? Well, let's start out with an example. We've got 0.687 is our decimal, and we want to know if it's rational or not. Well, we've already talked about how if you can write it as a fraction, it's a rational number. So if we can take this 0.687 and turn it into a fraction, it's a rational number. Well, I can do that. If you notice, I would need to move the decimal point over 3 spots to make it 687. So that 3 spots tells me how many zeros is going to be on the bottom. Okay. So if I had a different example like 0.4672, I want to rewrite that as a rational number. You see I have to move it 4 spots. So I would take 4672, I'd have it over 4 zeros with a 1 in front of it. Okay, so both of these are examples of rational numbers. There are 2 types of decimals that will result in rational numbers. And the first one is called a terminating decimal, which is a decimal where the number of numbers ends. So there's a beginning and there's an end. So these two examples that I did up here, 0.687, 0.4672, those are examples of terminating decimals because there's only so many numbers after the decimal point. The other example is going to be a repeating decimal, which are decimals in which one or more of the digits repeat. Those are always rational as well. Okay? Not quite sure what happened there, but the example here is 0.3 repeating. Okay, we know it's repeating because of the bar over top of it. Okay, so 0.3 repeating is a repeating decimal in which the digit 3 just keeps going forever and ever and ever and ever. That is going to be rational as well. Okay, so anytime we've got this bar here, we will have a rational number. Okay, so with that, it doesn't have to be just over one number. If I have 0.45 and then I have a bar over that, what that's going to mean is that the 4-5 is going to repeat itself over and over and over. That is still a repeating decimal, and it's still rational. So what about numbers that aren't rational? Okay, there are some. Some decimals don't terminate and they don't repeat themselves. They just go on and on forever and ever and ever. These are a special group of numbers called irrational numbers. They are not rational. We'll learn more about them in a later lesson, especially the main one, which is this sign right here, this pi. Now normally we say that pi is about 3.14, but that's a rounded number. Okay, really it's 3.141592 something 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 forever and ever and ever, and it never repeats itself. Okay, but again, that's going to be something for a later lesson. So here is the end of the introductory problem. Go ahead and read this before moving on to the next slide. Here's a review for all of the vocab terms we've had in this section. Make sure you have these written down somewhere in your notes before closing the window.